Today we will be discussing about ideal boil water properties and their effects. And ideal boil water, their properties. So let's move on to the topic. For an ideal boiler water, for ideal boiler water, the properties and effects of varying chemical compound in it, varying with the chemical compound in it. So it is very important to keep all the constituents should be maintained in their appropriate chemical range to keep the boiler water in ideal condition. Means the boiler water chemical properties and all will vary, will vary chemical compound in it. So it is important to keep all the constituents should be maintained in the appropriate chemical range to keep the boiler water in ideal condition. So let's look at the properties of boiler water. pH. For an ideal boiler water, pH is maintained between 10.5 to 11.5. That is because it is alkaline. So for ideal boiler water, pH is to be maintained between 10.5 to 11.5. Controlling the pH of water is one of the important treatment of boiler water, because we have to maintain the pH of water. It is one of the important treatment in boiler water treatment. We have to maintain the pH between 10.5 to 11.5. Mostly it is alkaline. So this controlling of pH of water is one of the most important treatment in boiler water treatment. pH below 7, we know the solution is acidic, and above 7 it is alkaline. Means from the childhood class we studied, this means the pH it is 7 means it is ideal, means it is neither alkaline nor acidic, but below 7 means it is acidic, and above 7 means it is alkaline. If either the value increases, water will accordingly become acidic or alkaline, leading to detrimental effects caused due to acidic attack or costly embrittlement. So we need to understand that if it is acidic, if the pH value get reduced, then it will lead to acidic attack, or if it increases, it will lead to caustic embrittlement. So oil and fats. For an ideal boiler water, oil content should be nil. So oil content should not be there. Lubricating oil may contaminate the feed system, and it finally reaches on boiler tubes. So chance of lubricating oil may contaminate the feed system, finally reaches the boiler tube. This is done to prevent the carbonization of oil and formation of scales due to boiler heat. This is done because of to prevent the carbonization of oil and formation of scales due to boiler heat. Proper care should be taken to minimize the oil in water emulsion. So we have to take proper care to reduce the oil in water emulsion. Effect is corrosion and carbonization. So if this is not there, there will be effect of corrosion and carbonization. If it is stick on boiler tubes, which will reduce the heat transfer, thereby reducing the boiler efficiency. If it is stick on the boiler tube, then it will reduce the heat transfer, thereby reduce the boiler efficiency. So oil and fat means for ideal boiler water, oil content should be in it, but lubricating oil may contaminate feed system when it finally reaches the boiler tube. This is done because to prevent the carbonization of oil and formation of scale due to boiler heat. Proper care should be taken to minimize the oil in water this emulsion, because otherwise there will be effect is corrosion and carbonization. If it is stick on boiler tube, then it will reduce the heat transfer and thereby thus reducing the boiler efficiency. Dissolved oxygen. For an ideal boiler water, dissolved oxygen content is 0.04. That means before scavenger addition. For an ideal boiler water, dissolved oxygen is 0.04. Dissolved oxygen is more corrosive than any other free gases in boiler water. We have to understand that dissolved oxygen is more corrosive than any other free gas, because inside it is chemically. For dissolved oxygen is more corrosive than any other free gas in boiler water. So it is very important to remove dissolved oxygen from it. This can be done by additives such as hydrazine to water. So hydrazine test we can remove this dissolved oxygen. So this means dissolved oxygen for ideal boiler water, dissolved oxygen is 0.04 before scavenger addition, because dissolved oxygen become more corrosive than any other free gas in boiler water. So it is very important to remove dissolved oxygen from it. This can be done by adding additives such as hydrazine to water. Hardness. The main purpose of controlling hardness is to prevent scale formation building on the interior surface. This can be done by keeping hardness value low. Okay, hardness means the main purpose of controlling hardness is to prevent the scale formation building on the interior surface. This can be done by keeping the hardness value very low. In case layers of scale keeps building inside the boiler, in case there are layers of scale that form inside the boiler, the insulation layer will reduce, which in turn prevent the heating of water and generation of steam. So this, if this scales layer that formed built up in the boiler, then the insulation layer will get reduced, so that way it will prevent the heating of water and thus generation of steam will also reduce. This will lead to overheating and damage to internal parts of boiler and reducing the overall efficiency. We have to understand that the hardness means main purpose of hardness is controlling hardness is to prevent scale formation and build up of interiors, prevent the scale formation on the interior surface, and this can be maintained by keeping hardness value low. Okay, because in you know that in case of layers, there are chance of layers of scales forming in the boiler. This insulation layer will be reduced which in turn will prevent the heating of water, then generation of steam. So this will reduce if the insulation layer is reduced. If the scales are formed in a layer by layer, then the insulation layer will be getting reduced. So the heating of water will reduce and generation of steam will also get reduced. So this will finally lead to overheating and damage to the internal parts of boiler, thus reducing the overall efficiency. Chloride ion. Chloride ion means standard value of chloride ion is less than 300 mgCl per liter. So that means chloride ion means standard value of chloride ion is 300 mgCl plus per liter. The more chloride ion, more scale formation is there. More chloride ion, more scale formation. So it is better to keep chloride low as much as possible. So it is better to keep the chloride low as much as possible. Formation of chloride ion can be done by controlling amount and the time of boiler product. So formation of chloride ion that can be controlled by amount and time of boiler product. Okay. Chloride ion means standard value of chloride ion is less than 300 mgCl per liter. The more chloride ion means more scale formation. So it's better to keep the chloride level as much as low as possible. Formation of chloride ion can be done by controlling the amount of time of boiler blowdown. Okay. Total dissolved solids and electrical conductivity. You can say 25% conductivity or less than 200 micro ohm. Total TDS means total solids and electrical conductivity. It should be at 25 degrees Celsius. It should be less than 2000 micro ohms. Increase of total solids will promote deposition of scale in boiler as well as in equipment consuming steam due to carryover. Okay, if the total dissolved solids is increased, then deposition of scale in the boiler will increase and the boiler as well as equipment, so that it will consume more steam due to carryover. So more amount of dissolved solids also lead to more scale formation and carrying on. So for more TDS, more dissolved solids also leads to more scale formation and carry over. P alkalinity. P alkalinity is phenolphthalein alkalinity. Phenolphthalein alkalinity in boiler water is between 50 to 300 mg CaCO3 per liter. Okay, we can say P alkalinity, phenolphthalein alkalinity in boiler water is between 50 to 300 mg CaCO3 per liter. This is standard value of hydroxyl ion. This is the standard value of hydroxyl ion and carbonate ion, that is CO3 in water. This is standard value of hydroxyl ion and carbonate ion, CO3 in water. Higher the value of P alkalinity, higher the probability of scales. If the higher the value of P alkalinity means higher the probability of scales. That means conventional boiler test find out the presence of OH and half of CO3. So conventional boiler test helps to find out only the presence of OH and hydroxide and half of CO3. Okay. Phosphate means standard value of phosphate is 20 to 40 PO4 per liter. That means standard value of phosphate is 20 to 40 mg PO4 per liter. That means phosphate react with calcium and forms calcium phosphate. So that means phosphate react with calcium and form calcium phosphate, which is a major scale forming component, because calcium phosphate is a major scale forming component. These phosphates also contribute to the prevention of alkali corrosion and caustic contribute to prevention of alkali corrosion and caustic embrittlement. So we know that phosphate also contribute to prevention of alkali corrosion and caustic embrittlement. Okay, phosphate means standard value of phosphate is 20 to 40 mg PO4 per liter. Phosphate react with calcium and form calcium phosphate, which is major scale forming component. Phosphate also contribute to the prevention of alkali corrosion and finally leads to caustic embrittlement. So we can summary, we can say appearance should be for the boiler water treatment, appearance should be clear and free of mud boiler water. Then chloride content should be less than 100 ppm per chlorine. P alkalinity should be 100 to 150 ppm CaCO3. The total alkalinity will be less than 2 into P alkalinity. Then pH at 25 degrees Celsius should be 10.5 to 11.5. So it should be alkaline. Then hydrazine excess should be that 0.2 to 0.5 ppm N2H4. Then phosphate excess should be 20 to 50 ppm PO4. Specific gravity at 20 degrees Celsius should be less than 1.003 kg per meter cube. Conductivity at 25 degrees Celsius should be less than 2000 micro ohms, and oil content should be nil. These are the basics that we need to maintain in a boiler water. Thank you.